Welcome to today's presentation, Glass 101, a crash course in structural glass and the requirements of the 2012 IBC Chapter 24. I'm going to cover, and the title says that this is based on the 2012 IBC. I will incorporate some aspects of the 2015 IBC and note differences between the two. I am going to cover quite a bit of material today, and what I'd really like to do, because glass is not a building material that's commonly taught about in schools. It's not something that as a civil or a structural engineer you go to school and have your course in glass. There are a few universities in the United States that do that. What this presentation is intended to do is really cover the basics of glass as a structural material and help us to understand the mechanical properties of glass, and then provide a general framework and some directions in which you can go in terms of resources for materials for actual design of glass. I'm not going to get into kind of in-depth examples about how to design glass elements. There is another webinar, I think in April, that will go over that, and then I'm always open to questions if you would like additional information kind of outside the bounds of this webinar. Please feel free to just contact me. So here I have an outline of just briefly what we're going to cover today. I'm going to go over a brief kind of introduction of glass in buildings, cover the general kind of mechanical properties of glass, talk in kind of large terms about glass strength, how we determine glass strength by two general approaches, an explicit approach and a stochastic or kind of tested approach. I'm going to go over the requirements of the 2012 IBC and a number of other design guidelines that are out there. And then I'll also, throughout this, cover just kind of some glass specific things, talking about laminated glass, IGUs, insulated glass units, etc. We will have 2 breaks, and I believe that this seminar is scheduled for 2.5 hours. So we'll finish up around 4:30 East Coast time. So before I start, I do need to thank the Cost Action Network, and COST stands for Cooperation in Science and Technology. It was a group in Europe that was together for a number of years. It did quite a bit of research and developed codes and other information regarding glass as a structural material. Quite a few of the materials in the first part of this presentation have been drawn from some of the materials that the COST network put together. So I do just need to give them a nod. Okay, so to get right into things, we'll start with glass in buildings and how it's been used. We've seen glass in buildings as a way to kind of connect the outside and the inside for many years. Being in a building without some connection to the outside world, imagine yourself in just a box with no windows. It's not the most pleasant place to be. So people for many years have been putting glazing in buildings to allow some connection to outside. And over the years, particularly in the last, I would say, 10, 20, 30, 50 years, the extent of glass in windows, or the extent of glass in buildings and building structures has drastically increased. We've gone from very small glass elements, just small panes in kind of a building structure, to full facades, curtain walls that are glazed from floor to ceiling, to glass structures that are entirely glass, in which you are transparent on all 4 sides. So in general, there's been an evolution towards transparency in building structures as kind of an architectural trend. And here I'm just going to show some examples of what you can do with glass. This is a canopy, or a glass roofed area at a medical school. And here we have glass beams that support glass kind of roof / skylight elements, and this gives you this fully transparent look. There's no steel or kind of larger structural elements that are restricting your view to the outside world. Here's an example of a glass stair in which we have the kind of banister on each side, or the stringer on each side, is a fully glazed piece of glass, and that glass actually acts like a stringer from floor to the 2nd level with glass stairs between. And I've seen a few different applications similar to this around the world. Not many examples here in the United States. People may be familiar with the Apple stores. I think these are the most iconic use of glass that we've seen in the last few years. This is a slightly more recent store in Shanghai, and this, I think, really shows everything that you can do with structural glass. Here we have glass columns that run from ground up to the roof. We have these curved glass wall elements. We have glass beams at the roof level supporting glass elements at the top. And so this is really incorporating many different aspects of structural glass. And then if you were to take that entry down into the Apple Store below, we have similar to the picture a moment ago where we have a stringer. In this case, it's a curved glass stringer that supports our glass treads.